Welcome aboard my virtual space station and to the second of our videos looking at how science is being used to help tackle the planet's changing climate. That thin blue layer surrounding the Earth is our atmosphere. In the last 100 years or so, humans have been messing it up, increasing the concentration of what's called greenhouse gases like carbon dioxide, CO2, with the result that the planet's getting hotter. We urgently need to reduce CO2 by cutting down on the fossil fuels we use like coal, gas and oil. An important way we can all help do that is by using more green energy and less energy overall in our homes. Down there in the UK alone, there are over 25 million houses and flats. Along with other buildings, they consume about 1/5 of all the energy used in Britain. It's time to link up with Jariah, who's at some climate-controlled warehouses in Manchester.
Hi Scarlett, yes, I've come to the Energy House Labs at Salford University where scientists are looking at how to make our houses greener. Let's go inside. Whoa! It's absolutely freezing inside here. We've already turned the temperature down to nearly minus 17 degrees. And for good measure, they're about to turn up the wind. To get out.
So Grant, you're one of the researchers here. I mean, I can't explain to you how cold it was back there. Who knew the wind could be that strong? So it's so unique, isn't it?
Yeah, so it's one of very few facilities like this in the world. So we have 3 chambers here, each of them with full-size houses built inside. So what we can do is make the temperature change exactly how we want it. So we can go from minus 20 up to 40 degrees. We can control snow, wind, rain and the sun.
We've come to the smallest chamber with the oldest house they're testing.
This house here is Energy House 1. So this is a pre-1920s end terrace Victorian house, like what you'd see in Coronation Street.
It's similar to about 1/5 of Britain's homes, and these old houses leak a lot of heat. So the team here have been testing out ways of making them more energy efficient.
So we've got 2 houses here. This house has had nothing done to it. It's really inefficient. Heat comes out of it really easily. Whereas this house, we've taken some measures to make the windows and doors more airtight so air can't pass through them. We've upped the loft insulation so less heat can go through there. But one of the biggest things we've done is add the external wall insulation. And that's like wrapping the whole house in a blanket to keep it warm.
To see how much heat is wasted on a freezing day like Grant has created today, I'm going to be using this device. It's a thermal imager which shows you how hot things are. So if I point it at Grant's face is boiling hot. And you can see all those oranges, yellows, bright reds. But if I point it at the ground is ice cold, really dark blue, and you can see purple on the edge there. Now if I point it at a building, it should be really cold from the outside, right? But check this out, it's actually pretty warm. And that's heat from inside leaking out through windows, doors, and the walls themselves. Loads of energy just being wasted.
So how much do the external wall insulation and the other measures help?
And now, for the moment of truth.
Whoa, look at that! So much less heat getting out.
It's like it's all sealed off.
The insulation makes quite a difference, especially when there's only so much you can do with an old building like this.
Wow, impressive energy saving for not much effort and cost. And it's worth remembering that most of the houses we'll live in throughout the 21st century have already been built. So it will really help us reduce carbon emissions if we ensure these old houses are as energy efficient as possible and powered by low carbon energy sources. But of course, it's also important that new homes are as green as possible, isn't it, Jariah?
Definitely, and that's why this even bigger chamber here at Salford University is devoted to testing out new houses. Check this out.
2 different full-size homes have been built inside this huge chamber, using all the latest insulating materials and energy-saving features. They're furnished just like typical family homes, but they're also full of scientific kit and sensors to measure their energy efficiency.
So it's quite easy to miss, but we have solar panels up there which create greener energy from the sun.
Yep, so we've got about 20 on the roof of this property. What they can do is feed into the home energy system, and we can power our heating systems because it's all electric heating in these properties, as well as your kettle, your TV and everything else in the house.
Solar panels are a huge source of the world's clean energy. There's something like 3 billion solar panels down there capturing sunlight. People first started using the panels in the 1950s.
Each of the dark discs is a cell. Just let the sun shine upon it and you get an electric current.
But it's only in the last 20 years or so that they've really taken off, as the cost of solar panels has plummeted. They supply electricity to millions of homes across the globe, with more and more huge solar farms like this appearing. And they're actually really important up here too, to power space stations and satellites. The panels rely on an effect first discovered by a brilliant French scientist, Edmond Becquerel, almost 200 years ago. Aged just 19, he noticed that when light fell on some special materials, an electric current was created. Nowadays, the material used most is silicon, and in one common kind of solar panel, there are around 60 or 70 silicon cells. When the sun shines, each panel can make about 400 watts of electricity, enough to power several computers and TVs. An average house might need about 15 to 20 panels to power everything, but of course, the less energy the home uses, the fewer panels are needed.
This house is so much better insulated from the word go than the older home. I mean, look at that, dark blues and purples. There's barely any heat escaping. One of the other features that makes these houses more energy efficient is this. This is called a heat pump, which is blasting out even colder air. To learn more about how they work, let's head up 200 miles to Scarlett on her space station.
Heat pumps really are a brilliant invention because they're just so much more efficient than boilers or other heaters at providing heat for our homes. The idea is a bit like the reverse of a fridge. Your refrigerator takes heat from inside, making the compartment really cold, and transfers heat to the air outside your fridge. You may have noticed it often gets quite warm around the back of your fridge. A heat pump kind of does the opposite. It takes heat from outside your house and transfers it inside. It still uses power, usually electricity, to do this, just less of it, and that electricity might hopefully be coming from a clean green source. On a cold day, you may think there's not much heat in the outside air to transfer inside, but the heat pump can still cleverly work to outside temperatures as low as -20 Celsius, though of course it will require more electricity to work well in these conditions.
All this groundbreaking Salford University research is helping the country come up with a greener plan for building our new homes.
Any house built from 2025 onwards will have to be built to something called the Future Home Standard, and both of these houses have been built to that new standard. So what that means is not only does the insulation of the walls, the loft, the floor and even the glazing panels have to be better, also how the house is heated and the energy systems of that house.
It's a huge improvement, but actually the biggest source of all for carbon emissions is the building of modern homes in the first place. So engineers and designers are coming up with some exciting ways to cut down on this.
So one that's been in early testing here at the Energy House Labs is the Vector Homes Rapid Build House. Believe it or not, it's kind of like a giant furniture flat pack which has been assembled from pre-built modules.
All constructed from low-carbon recycled materials.
So Grant, what's the advantage of this?
The advantage is that they want to build standardised components that are really lightweight and really easy to put together, a bit like Lego for adults.
It means the materials can be transported on far fewer trucks, and homes can be put together rapidly by just a couple of builders. And if later you need an extension, along it comes pre-built and can quickly be bolted on to the existing house.
Just one of many ingenious ideas to make sure that for the rest of this century and beyond, our expected population of 10 billion humans can live down there on our precious planet without destroying it.